what new opportunities can come about if we were able to, open the eyes and see magnetic fields rather than seeing light? Or what does that open up, and how can we harness that? So that's kind of like the concept that how we're thinking about detect.
Imagine a world where computers don't just calculate faster, they think in fundamentally new ways. That's the promise of the quantum technology industry, which is a billion-dollar industry projected to be valued in the hundreds of billions by 2040. Why should you care? Because quantum technology could reshape the world. From drug discovery to financial markets, supply chain logistics to advanced materials, quantum tech promises tools that could solve massive optimization and simulation challenges in seconds, problems that would take today's computers millennia. This isn't sci-fi. The foundational science is already real, with companies and governments pouring billions into research and development. This episode is going to be a little different than usual. We're diving into the world of quantum technology, which means we'll be tackling some complex ideas and using words like magnetometers and qubits. I promise you'll learn a lot. Today's guest is Dr. Jim Rabeau, an international leader in quantum technology and innovation.
We're making quantum mainstream by connecting it with these semiconductor superhighway.
With a PhD in physics and a career bridging deep science, entrepreneurship, and industry, Jim has spent decades turning breakthrough ideas into practical technology.
Bring in AI and quantum, there's a lot of consideration about what the impacts are going to be.
He's the CEO and co-founder of Detect, an Australian startup that's revolutionizing navigation through quantum magnetometers, compact diamond-based sensors that bring quantum precision into the real world.
Out of the lab into the commercial opportunities.
Get ready. Today's conversation will teach you about the latest technology you won't want to miss out on. All right, guys, I'm really excited about today. Welcome back to the Mellow Millionaire. Today's guest is a world leader in quantum technology and innovation. With a PhD in physics and a career bridging deep science, entrepreneurship, and industry, Jim has spent decades turning breakthrough ideas into practical technology. Jim, it's a pleasure to have you on today.
Nice to meet you, Tommy. Thanks for having me.
So I don't know if there's an easy way to explain what you do, but tell us a little bit about the journey, what you're doing today, and what you're excited about.
Okay, well, let me go back quite a ways to the PhD. That's what really started things off in terms of the science and tech that I've been passionate about for about 25 years. In my PhD, I grew diamond films in a lab. So basically turning gas with carbon in it into thin layers of diamond. There's lots of interesting applications for that. Electronics, hard coatings on drill materials, blades, and so on, and thermal conductivity. But at that stage, early 2000s, there was a lot of excitement and growth in the quantum, especially quantum computing. So how can you use quantum objects, quantum particles to do really powerful computation? So that got me into applying, the diamond materials to learning how you could use them in quantum technologies. The work I'm doing is more around sensing and magnetic field sensing. So there's all these things that we can kind of tap into, either developing technologies to measure or affect magnetic fields to do interesting things. But what's really fascinating to me is how, we weren't designed and we didn't evolve to be able to see or measure magnetic fields as humans. But some animals can do that, right? And so birds and turtles have this ability to navigate with magnetic fields. And the turtle example is kind of the most interesting to me. A turtle hatches on the shore somewhere, and it's able to imprint these magnetic features that I was talking about earlier in the Earth's crust. So not just saying, okay, here's north and south, but rather they can imprint kind of this map of where they're hatched. And they go and they swim, to the other side of the world, and they're able to find their way back because of the ability to sense these fields in the Earth, and find their way back to, roughly the place where they were hatched. It's not fully understood, the physiological mechanisms that make this work, but birds as well, they can, navigate themselves in different migratory patterns, but they can orient themselves quite accurately to magnetic fields. And so it's just fascinating how if you think about the human body has sensors, right? You can open your eyes and you see the world around you, and you see that because light is coming into our eyes. Now imagine what animals are doing, or imagine being able to open some sensory mechanism and be able to see magnetic fields. And what does that open up for us, right? I mean, we know that animals have some way to do that, essentially sense fields, and they can navigate with this. So this kind of concept that we're thinking about as saying, well, what does it open up? What new opportunities can come about if we were able to, open the eyes and see magnetic fields rather than seeing light? Or what does that open up, and how can we harness that? So that's kind of like the concept that how we're thinking about detect and making our sensors small and deployable, that we can start to see fields that we haven't seen before, whether that's in the human body, underground, for different applications. So basically, the Earth is a big magnet. It's got metallic material kind of spinning around, and that creates a current. And so we have this. It's like a big magnet with a north and a south. And that just is pervasive, right? Like through this room right now, there's magnetic fields traveling. We can't see them. And they're used in technology in many ways, like a hard disk uses magnetic signatures and sensors to save data. I always had this entrepreneurial bent and decided to leave academics, and I worked at Deloitte as a consultant, and I just was moving around in the business world and trying to learn, build networks. That brings us to today, where I'm now the CEO of a startup company called Detect. We're developing a magnetic field sensor that has a whole range of possible applications from navigation to mineral exploration to medical sensing. Quantum mechanics, there's two kinds of descriptions of the world. There's classical mechanics. It describes the way the world that we can see around us, the way it works. So it's enabled us to, for example, build planes that fly because of the forces at work. So very functional, accurate at a macro, at a large scale. Over the last 100+ years, we've started to understand things at the really, the small scale, like the scale of electrons, the scale of single particles of light. And it turns out, so that's the quantum world, so quantum mechanics. And that things behave much differently at that scale, right? You can't predict as easily as you can like a tennis ball. So if you imagine shrinking a tennis ball to the size of an electron, which is incredibly small, electrons behave in different ways. There's certain characteristics like superposition and entanglement. These behaviors, if people have really started to think about them probably in the last 30, 40 years about, well, what could you do with these if you could harness them? And that's what's led to things like quantum computing. You can do really powerful computation much better than in just using zeros and ones like we do in our computers now. So that's one thing. Another thing that you can do is these are very fragile states of matter or light. If you can tap into them, you can use them as sensors. So now imagine being able to look at them with a technology that we build around it. And then each time a magnetic field changes really, really small, a really subtle change, you can detect that. So quantum is just a kind of a tool that enables us to tap into the world around us in ways that we haven't been able to before. And that includes computing, sensing, communication. So those are the three sort of big pillars. There's this rigid crystalline structure that has these quantum objects, nitrogen atoms trapped inside it. We can actually use that crystal as a sensor of magnetic fields, again, building electronics and optics around that. Right at the beginning of COVID, 2020, you got a grant from the Australian Defence Force. We've designed and fabricated a tiny silicon control chip, much like what you get in your phone or computer, that interfaces with our quantum chip. So we have two things. We have the quantum sensor and we have this semiconductor, which is really mainstream, very scalable. Putting those two things together, now we have this technology that can measure magnetic fields.
So you've got communication, navigation, and detecting. You want to just give me a summary of each of those, how it works?
Here's how this works. Right now in the Ukraine, there's no satellite connection. Satellites are there, but they're being jammed. So in conflict zones anywhere, really, the satellites become inaccessible. The same thing happens in a tunnel. When you're driving somewhere, you got your GPS going, you go into a tunnel, you lose that line of sight. So suddenly you don't have accurate navigation. In fact, you don't have anything. It's just sort of guessing where you are. Underwater submarines, they don't have a line of sight to satellites, so GPS doesn't work. So in these different scenarios, like whether you're underground or underwater or in a conflict zone where satellites are basically being knocked out, you can't navigate reliably with GPS. So this is a pain in the butt when you're trying to navigate to, a new restaurant or something in the city, and you go in a tunnel and you get lost. When you're in a conflict zone or when you're underwater with a big submarine, it's not just a pain in the butt, it's actually very problematic. So there's this urgent kind of pressure right now, or military globally, to solve how do you navigate without GPS, getting into how magnetic field sensing and the tech that we're developing, which is all about measuring magnetic fields. How does that come into it? Well, the Earth is just like this big spinning magnet. These are big, strong fields. Now, what happens in underground where there's blobs of metallic objects and different things, basically those field lines kind of get wavy and they move around, like there's texture to them. What that then looks like for us on the surface is that those wobbles and things that, around these objects underground create essentially a map, a magnetic field map. Now we have a way to sort of say, okay, here's the surface of the Earth, rather than thinking of a road map. Well, you've got this magnetic path that you can follow, because you know that if you have a map of what those magnetic anomalies are, you can use that to locate yourself with a sensor on the grid, if that makes sense. So essentially replacing a road map with a magnetic field map, and then using a magnetic sensor kind of to track yourself around. And that's a completely independent of satellites. You can actually have something in your hand, like I'll just hold up my phone here. It's like our device currently is around this size, a bit thicker, but it measures the magnetic field. So if I have a map in my hand on one side and my sensor here, and I can link it to the map, you can then navigate without GPS. And that's hugely valuable, especially in the military context. It makes them independent of satellites. So there's a real security aspect there that they're driving for.
It sounds groundbreaking. I mean, it sounds like how far along are you as far as dependability? Is like, what phase are you in?
There's been demonstrations done by other technologies to demonstrate that you can get GPS level precision with magnetic field sensing, quantum magnetic field sensing specifically. Where we're at as a company, we've kind of taken a slightly longer path and really focused on the hardware and the scalability. And that's where semiconductors come in. So our effort has been on designing and testing a chip, millimeter scale chip that we interface with, that we connect with the diamond. And that is solving one of the biggest challenges for all of quantum technology, and that's scalability. Like, how do you make a lot of these things at a reasonable price point? And because quantum tech is so complex and sophisticated in terms of the technologies that you need to integrate together, this is a big kind of roadblock. The next steps over the next 12 months, and what we're raising this seed funding round for right now, is to really focus on testing it out in the field.
Yeah, I'm very, very interested in that, because I'm just thinking about, like, as you know, Venezuela has some of the most resources around, and if you're basically building kind of a treasure finder in a lot of ways.
It's like we're moving the base technological capability in certain areas beyond what we've ever been able to do before. And when you do that, you're going to discover new things. You're going to enable new things. And this is why in the commercial world, these new valuable things are starting to emerge, and people want to get on board. And so that's why, 20 years ago, investors wouldn't really have looked at too closely at quantum tech, but now it's becoming more tangible and real.
Magnets seem to be a hot topic. I know that China has kind of really reined in a lot of the magnetic development. Let me ask you a few repeat questions I ask, and I'm just curious if you could go back and talk to yourself in your early 20s. What piece of advice would you give yourself?
That's a really great question. In my early 20s, and this is something I'm still learning, is where you're not alone in making mistakes. The idea of, especially being a CEO of a startup, it can be kind of isolating, right? And you're going to screw up. You're internalizing that and saying, I failed at this, and that can really drag you down. But I think it's really important to actually embrace it and understand that you're not the only one who's gone through and hit walls and made a mess of things. But I'm certainly still learning. The older you get, the more you kind of are aware of yourself, I suppose.
I was going to ask you, so as far as what you're working on today, what does success look like? What does that mean? If you were to look back in 30 years, you'd say that's what I made it. That was it.
One answer is that I exit, or we list on the stock exchange, or I exit, somebody acquires a company and we make 100 million. For the success of the company, I would love to, what I want to get to is that our device, our technology is taken up in real applications broadly. We want to make a magnetic field sensor that's going to open up something that we're calling magnetic field intelligence. So this like ubiquitous deployment of sensors that can tap into information all around us, because magnetic fields are all around us, right? So that's, for the company, that's what I want to get to. For Jim, the answer for what does success look like for Jim, I think about this every single day. I've got 3 kids. They're in their 20s. Got parents in Canada. I want to see them at Christmas time. Siblings over there as well. It's about looking back and saying, I made the right decisions when it mattered. I chose the right things that really matter, and figuring out what those are is actually a little bit more challenging, but not choosing to forego, the things that are important, like my kids and family and so on, because of the success of Detect. And I think, again, as you get older and more self-aware, I think that's probably an easier judgment call to make. But I certainly don't want to end up in 30 years saying, damn, I wasted 15 of those years not having the time that I really would have loved to have with the kids. So that's how I'd answer that, Tommy. I think it's having that balance, because in order to be successful, you do have to forego some things. It's just, where's that line? And so, just as an example, I was exhausted yesterday at the end of the day, but my son and I went and saw AC/DC. I've never seen AC/DC before. They're here in Sydney, and he's 21 and blown away. We went, and I was kind of like, oh, geez, I wish I had the night in, but AC/DC and my son, we're sitting there taking this in, and I don't think we'll ever see them again. And he was videoing, the different songs that we've been listening to for the last 15 years together, and it was just the best thing. And I'm like, I'm so glad this happened.
I love the answer, and you're right. There's going to be sacrifices. The best advice I ever got was be where your feet are, be all in. And it's hard for entrepreneurs to not be thinking about what we're excited about, even though we're all excited about our families. It's just, there's so much work to be done. But then all of a sudden, a year goes by and then a decade goes by. You're right. There's a weird balance, and it's off balance. And I think that's okay. What do you think, what are your biggest challenges?
I think that's the number one challenge in building the company, is putting the required time and effort and diligence into recruiting the best people, but also having the culture, defining and having the culture that enables you to be a magnet for great talent. I was fortunate very early on in recruiting. I got my COO on board, and she's just been phenomenal at kind of doing all the things that I'm not good at. Where I'm kind of out in this direction and high level, she's very much operational and structure, and has just been ticking the box on all the different things that we need to build to have this strong foundation of company and then become that magnet. And then, learning this very early on, and it's really hard, is like literally really early on when you're sort of a handful of people, recognizing when you didn't hire the right person. And so what do you do with that? And how do you address it? And being a leader and taking a hard decision, for the good of the company. So there's hiring the best and then making sure that you don't hold on too long to somebody who you realize is not a fit.
A B player is the worst employee because they're never going to take you to where you need to go, but they just do enough to kind of stay alive. And, but A players don't like B players, and you're going to get worse performance out of the A players by keeping a B player. But B players, they kind of are incognito. You don't really see it, and it's really hard to see it, but you can almost tell by the way the A players are performing that they're holding them back. One of the questions is, quantum sensing market is projected to be a $6 billion industry by 2040. Which industries do you believe will be impacted first?
I think that navigation is probably the earliest one where we're seeing the most traction, and mining. So those two things kind of go hand in hand in enhancing our ability to find critical minerals underground. I think as we push the boundaries out further, the technology gets more advanced. I think I'm really, really excited, and I think it's a huge, beyond those numbers, huge market opportunity and huge benefit potential is the medical diagnostics space. I mean, the human body has so much electrical magnetic information signatures that like the heartbeat, do an ECG and you can learn a lot about how the heart is, what the heart rhythm is, and you can diagnose things. MRI, magnetic resonance imaging, is, you might have even had one on your ankle, I don't know, but so that enables you to see the density and the, changes and injuries in the human body that you can't measure with X-ray. There's so much information there. And if we can push the boundary of what you can measure a little bit further, and then it opens up new information, new, more rapid diagnosis and so on. So that's something that I'm also really excited about.
What are your thoughts? I've talked to a lot of people in the past that are just light years ahead of my IQ. But I feel like I'm just curious your take on this, because there's EQ, which is emotional intelligence, and then there's just like photographic memories and people that just understand the deepest comprehension of certain things.
I've worked with a lot of people who, like my IQ is not near the level of a lot of people that I've worked with over the years who are, quantum or physicists or scientists who really deeply understand things and can see things in numbers or in data and interpret it in ways that I could never get to. With the the case is that the EQ broadly defined is more lacking. It's communication. How do you communicating a hard topic, right? That might be really challenging for somebody with that very narrow, deep IQ. What I'm trying to do is, when you're trying to bridge both, right? You're trying to bridge something that is deep quantum or deep technology, which is just called deep tech, with the EQ requirements of running a company and building that team that we were talking about and becoming a magnet and having the culture.
What's one thing you wish more people understood about quantum technology?
Quantum is a fundamental way that the world works, right? It's it describes how the world works. So it's fundamental. We're tapping into that in ways that enable us to do things that we haven't ever been able to do before. For example, sensing something that you can't sense with normal sensor.
How is AI going to affect your research going forward?
AI is amazing. Like I can't believe how fast things have moved there. So we're using it in the company to help, whether it's understanding or accessing a wider range of perspectives on a certain technology problem, or how do we communicate something better. In terms of like our sensors and the types of data that we're going to be pulling in, we'll certainly be looking at using AI to interpret that and enhance like what the overall solution to a customer might be. So I think for us, it's like trying to leverage it as much as possible in both in the business side, but also in the tech side.
The world could be so small if you just think about money and business and corporate development and just the things that it's just expand your horizon. And this was so fun to just learn about what's possible and what intrigues guys like you, because it's just the world's going to be changing so much quicker. I mean, 3D printing and what we're exploration. Like there's nothing more. We're building a place in Sandpoint, Idaho, which is really far north near Canada. And just looking at space and just thinking like beyond ourselves. Do you ever I don't know I didn't really do any stargazing in Australia when I was there, but do you ever just look at places and you're like, wow, we're at the cusp of just learning so much more?
I had literally the same thought. We at this AC/DC concert yesterday, and I was thinking, like I've got all these, I had a lot on my mind. I'm thinking about solving, negotiations and all of this. And we were sat up on like the second tier-ish. So looking out over all the people on the floor and in the stands. And I just almost had that same kind of stargazing moment, but in reverse, where you're looking at all these individual humans down there. And it's kind of like all those people having different perspectives on the world. And it also gives you the similar view of like, in some ways, like how insignificant your little world is, but yet so important to yourself. I love that visual of the Ant-Man shrinking down, into this, imaginary kind of like universe of things. I love that stuff.
I'm very cautiously optimistic about AI, and I'm not like the end of time or anything, but it's definitely, I'm ready for it and I accept change, and I'm more of a first implementer. Like I love to go deep into things and like not be afraid. But yeah, there's so much to think about. And, unfortunately, I've been very successful with business, but there's so much more. So let me ask you this, and we'll wrap up here. What is a book that just means a lot to you?
I'll tell you the book. I'll tell you the book that I really found impactful. Is Eckhart Tolle. He wrote The Power of Now, and he also then followed that up with A New Earth. And my mom gave it to me like 20 years ago or something. And I think I've got 3 brothers and 2 sisters, and I think she gave all of us a copy of that book, A New Earth. It's more about like consciousness and humans and being in the present, right? Like some really powerful kind of like ways to approach being in the present. And I just found it, especially sort of through the time in my 30s where, there's challenging stuff. You're raising kids and you're trying to do your career. And I just found it really powerful to help me. And I still go back and read bits of that book. What's the one by, Never Split the Difference? Yeah. Which I've also heard about for a long time. And I picked it up not long ago. And it's pretty, great read. That one I did read end to end. And, you probably need to read that several times to really embed all the components. But yeah, that was really, really interesting, really useful as well.
Yeah, if you ever want to meet Chris, I've got to know him really well. He's out in Vegas. He just was with me at my last event. So he's a fun guy. Awesome. And then we talked about a lot of cool stuff. I never thought I'd be as into electromagnetic sensitivity, but we'll let you close us out on anything you want to wrap us up here, brother.
Well, I just want to say, Tommy, it's awesome to talk to you. Like, I admire that you're like I said, pushing the boundaries and diving into something like this. And I think we're at this exciting time of quantum technology that is kind of like, it's been in the lab and a research thing for many, many years. And we're really at this precipice of saying, okay, what can this really do in the world around us? And so I was excited to share that with you. And thanks for contacting me and setting this up.
Yeah, I definitely want to stay in communication. I want to see how this all comes together, and I'll be praying for you. I mean, look, it sounds like you got a good grasp of everything. You got a strong team, but I think you're in the beginning stages of something that's going to be super fun. And when you look back, it's you're building. I always like to say, like, I'm fascinated with Back to the Future. I have a DeLorean that's made up like Back to the Future too, and you're like, where you're going, there are no roads because you're building your own roads. So it's going to be awesome.
I love that. Oh, DeLorean, man, like that's. I think if you ask me that success question again, I would love a DeLorean.
If you get out to Phoenix, come visit. I'd love to have you out here, and you're more than welcome anytime. And I'd love to take you for a ride. I'm getting an electric motor put in it just because those motors weren't super reliable. So now this thing will do 0 to 88 in about 6.8 seconds.
Amazing. That's so good. No, I definitely will keep in touch. And if I'm ever in the neighborhood, I'll ping you. And yeah, thanks again. Appreciate the chat.
This was a great podcast. Thanks for the listeners for listening. Hopefully you got something out of this, and I hope you guys are having a great day.
Thanks so much for listening to this episode. Like always, we're going to close it out with the Tommy Truth, which is a little slice of wisdom from me to you that can help guide you in whatever you're striving towards right now.
Do you know less than 5% of businesses ever cross $1 million in annual revenue? Your chances are 1 in 20. And the reason why is most people underestimate what they could do in 5 years and overestimate what they could do in a year, and they give up. There's a great book about this called 3 Feet from Goal. And the best answer I could give to you is don't give up, make a plan, reverse engineer it, and stay the course. Go for the long term. Start to learn how to build teams and not be so reliant on yourself. Businesses that track key performance indicators grow 60% faster than those that don't. When you know the score, it's a lot easier to win the game.
And that's it, guys. We'll talk to you next week.